Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphed inequalities, specifically how we can find solution sets for graphed inequalities, and we'll do it in 5 minutes or less. So we see here a graph of this inequality, 2x minus 3y is less than 3. And I want to point out a few things, because this is what we know about when we graph inequalities, right? So when we have a less than or a greater than symbol, it's going to be a dashed line. So that's what we have right here on the graph. If you ever get a less than or equal to or greater than or equal to, then that's when you're going to get a solid line, because that means it includes the numbers that show up on the line. And also, when you see a less than, that means it is going to, the graph that is shaded, the solution set is going to be below the line. And if it's greater than or equal to, then the solution set is going to be shaded above the line. And you might be thinking, wait, it looks like you've got a less than, and yet it's obviously shaded above the line. Well, that's because this is in standard form, right? So just because it's in standard form doesn't mean that it's going to stay the same. So let's go ahead and switch this into our slope-intercept form. If we can get it to look like this, then you are going to see a slight change, right? So what do I need to do? I need to get rid of this 2x. I'm going to subtract 2x from both sides, right? So I'm going to get minus 3y is less than negative 2x plus 3. Now I want to isolate that y, so I'm going to divide both sides by negative 3. And what happens here is when you multiply or divide by a negative, you end up flipping the sign. So that's why it's actually y is greater than, and those two cancel out, so we can distribute this negative 3 out to both, right? So it's going to be 2/3 x. That's why it's a slightly rising. And then you have a plus 3 minus divided by a minus 3, so it's just going to end up be a minus 1. So that's what this exact same thing looks like in slope-intercept form rather than my standard form, and you notice that my inequality changed. So my solution set would be any point that shows up over here. You could take the x and y of these points that I'm plotting right here, and you can plug them into the original, and they would be true. Let's look at another example. So what we see here is the graph of this linear function right here. Y equals negative 1/4 x minus 1. And so the question sometimes we get in Algebra 1 is, what if we were to simply turn this into an inequality? So we're going to replace our equal sign with our greater than sign. So first we have to identify where's the shading going to be, what type of line is it going to be, and do any of these points actually lie in the solution set? Well, it is a greater than sign, so what I'm going to do is I'm going to kind of draw over this. I'm going to draw a dashed line. So if I get any of these points that are actually on the line, I cannot include them because it's a dashed line. Since this is in my slope-intercept form, I don't have to worry about it flipping inequalities. If it's standard form, you need to put it in slope-intercept form. But right now, we are in our slope-intercept form, so that's good. Which means it is a greater than sign, which means it's going to be shaded up above. Okay, so here's my solution set up here. It's a dashed line. So now all I need to do is plot these points, right? So I've got 5, negative 5 is right there. Okay, so I'm going to put an x. It's not in the solution. I've got my negative 4, 0. Oh, now watch this right here. So here's my 5, negative 5. Clearly not in the solution. Look at that. It's right on the line. Negative 4, 0. But you know what? That's a dashed line. It's not a greater than or equal to, which is a greater than, so I cannot include it. And then look at this 2, 6. So here's my 2. Oh, that's easily in our solution set. And then negative 10, 5. That's also in our solution set. Right? And if you wanted to, we could take any of these. Let's take this negative 4, 0, and let's just plug that in. 0 is greater than negative 1/4, negative 4 minus 1. 0 is greater than, that's going to be 1 minus 1. 0 is not greater than 0. If it were a greater than or equal to, we could have made it work, but it's not.